So here we're going to look at how we do calculations with percentages. So up here we have kind of a basic form where we have A equals P times B, where A represents this amount, P represents the percentage, and when we work with our percentage, we're going to work in decimal form of our percentages. So we'll have a little conversion to do there, and times the base. So base is kind of a starting value in that we're taking some percentage of that starting value. And then what we're left with after taking that calculation is the amount. Now, in terms of wording, what you're going to see in sentences is that we'd phrase it as the amount is the percent, something percent of base. So something I want us to see here is that when you see the word is, that often relates to an equal sign. So if we're translating from words into a calculation, is can be replaced with an equal sign. For these cases where we are dealing with percentages, when you see the word of, that's going to relate to the multiplication symbol. So we're going to use these kind of key words for translating between English and math so that we can do our calculation. So let's see how this works. So first off, we're going to look at these and calculate them and also talk about how they differ. So what is 8% of 300? So if I wrote kind of some quick notes to myself, we have an unknown, we want to know what, and then where I see is, I'm going to put an equal sign, and then we're taking 8% of, which is going to be our multiplication symbol, 300. So there I start to get an idea of what this is looking like and what I'm solving for. So where I have my unknown, I'm just going to call that x, and then is 8% of 300. Now again, I want to use that percentage in decimal form, so what I'm going to do is a little conversion. So 8%, if I have my decimal right there, I move it to the left 2 spots. So this is the same thing as 0.08. So I want to take 0.08 times 300. And from there, I can just use a calculator to help me out. So just need to find my mouse. There we go. 0.08 times 300 is 24. So it's the idea that we have this sentence, 24 is 8% of 300. So that was our calculation there. We ended up finding the amount. That was something that happened here, is that we solved for the amount given a percentage and base. So the base is 300 is our starting value, and then we're taking a percentage of that to find the base. So now this has similar wording, but in a slightly different order. So we're saying 8% of, which is going to be our multiplication here, and then what, so our unknown, and then we have is equals 300. So what changes here, so how these differ, is that really the percentage stays the same, but we're changing the amount and base. In the first question, the amount was unknown and 300 is our base. In the second question, it's that the base is unknown, but we know we end up with 300 in the end. So the setup of this one, I'm going to have my 8%, but I'm going to put that in decimal form, times, and then our unknown, which I'm just going to call x, equals 300. And then I want to solve for x, which means I want to divide both sides by 0.08. So x equals 300 divided by 0.08, which I'll use a calculator to help me out there, which is 3,750. So what we found here is that the amount is 3,750. Nope, sorry, the amount is 300. So the amount is 300 is 8% of 3,750. So for this case, we were solving for the base value instead of the amount because of the phrasing there. But if you use those key pieces like is relates to equals and of relates to multiplication, that can help get the order correct. So let's do the same thing with these. So it says 18 is what percent of 30? So if I make kind of some notes to myself, 18 is what percent of 30? So how I can go about solving this is 18 equals, and for the percentage, I'm just going to put x there, times 30. And to get x all alone on one side of the equation, I just need to divide both sides by 30. So x equals, and then 18 divided by 30, which is 0.6. Now, just be aware with our calculations, it's going to give you the decimal form, so this is not 0.6%. Instead, what we need to do is convert it. So to convert it to a percentage, we're going to go 1, 2. So this is the same thing as 60%. So I would say that 18 is 60% of 30. So let's see how this differs from this question here. So we're saying what percent of 30 is 18? Now notice this setup here, especially if I change it to the form of x times 30 equals 18, it's the exact same equation as up above there. These are the same. So what we would get is the same solution of 60% of 30 is 18. It's just slightly different phrasing, but it says the same thing in the end. So sometimes you can have wording for two things that are actually exactly the same. All right, so with these, we're just going to translate and then calculate. So what is 32% of 51.2? So again, is my equal sign, of is my multiplication. So what is 32%, but in decimal form, that'll be our 0.32 of 51.2. So this is just going to come down to multiplying in a calculator 0.32 times 51.2, which is going to be a 16.384. Now here they didn't give us any rounding rules, so we can leave it just like that. Sometimes they'll have us round to 2 decimal places. So let's say if it said to round to 2 decimal places, then what we would write is just 16.38, since again with rounding, if I was rounding there, I'd be cutting off there, and the 4 would have us round down, keeping that value of 8. All right, 9 is 40% of what number? So 9 is 40%, which is 0.4, times our unknown, which is x. So to get x all alone, I'm going to divide both sides by 0.4. So x equals 9 divided by 0.4 in a calculator, which is 22.5. So we could say 9 is 40% of 22.5. Our last one here, 50 is what percent of 90? So 50 is what percent of 90, and I'm going to divide both sides by 90 to get x. And let's go to the calculator together with this one. So 50 divided by 90, it's going to give us this long repeating decimal. So we don't have any rounding rules here. It doesn't say specifically. So what I would do is, let's go ahead on our paper, just write a bunch of them. But notice at the end, it does round for us. It is 0.5 repeating forever. I'm just going to write down a large portion of that. So let's say I write down 0.555555556, something like that. Now, let's say we can do some different things here. What we can do is, typically if they don't say what to do, and especially like if you're working in MyOpenMath, I typically like to round to 4 decimal places. It gives a lot of accuracy, and it's especially if I'm working with percentages. I like to round to 4 decimal places for my decimal form. So what I would do is 4 decimal places. So right there, I would cut off, and then notice that we would round up. So rounded to 4 decimal places there would be 0.5556. But remember, we're asking for a percentage, so I need to convert this. So what I'm going to do is move my decimal place to the right 2 spots. So this is 55.56%. That would be the answer I would go for if there weren't any rounding rules specified. Try to keep as much accuracy as possible, but when it's repeating like this, it can get a little messy. Some of you might be used to the notation, like that could be written as 0.5, and then you would write a line over the 5 to show that it repeats forever. You could do that in percentage form as well. How you would write it is 55.5, and then with a line over it to show the decimal repeats with the percentage. That absolutely works as well.